Hey guys, I hope you're ready for some more identities today. In the last video, we talked about sum and difference, so adding and subtracting angles inside of a trig function. Today, we're going to talk about what happens if I have a double angle, so an angle times 2, or a half angle, an angle divided by 2, and how we deal with that. Okay, so the double angle formula is really easy to prove. It's a nice progression from the ones that we learned in the last video. So we're going to use our cosine sum. So again, hopefully you can recall that. I'll give you a second if you want to try to recall what the cos of alpha plus beta is. So the cosine sum or difference is, I always start with this. It's cos, cos, sine, sine, first angle, second angle, first angle, second angle. And remember, for cosine, it switches. So if it's addition here, it's subtraction there. Okay. Okay, so we can use this to find a double angle because what we're going to do is to find cos of 2 alpha, which is like doubling an angle, right? I'm going to treat that as just alpha plus alpha. Okay, so let's see what happens when we do cos of alpha plus alpha, which is really cos of 2 alpha. So I'm going to use that little piece. Okay, if I do that, then that would be cos of the first, cos of the second, which they're the same angle, minus sine of the first, sine of the second, again, same angle. So what we notice here is since they're the same angle, we could call this cos squared of alpha. And these are the same angles, so sine squared of alpha. So there we go. There's our first identity for cos 2 theta, or 2 alpha. So cos of 2 alpha, so if you have a 2 inside, again, the common misconception here, for example, if I had like cos of, excuse me, if I had cos of 2 times an angle, some people would try to say, oh, I can just do 2 times whatever I get when I do the cos of the angle. That's the common misconception. No, it's not like you can just bring that 2 out. So that is the common misconception. If you have a 2 inside, you have to use this expansion. But you might notice because I have these cos squareds and sine squareds, I can manipulate this a little bit using this trig identity, Pythagorean identity that we learned. So for example, yes, I can use cos squared minus sine squared, but I could also replace the sine squared with a manipulated version of this. So remember, I could also say that sine squared theta, oops, I'll use theta, equals 1 minus cos squared, right? We learned that, we saw that happen the other day. This is literally me just manipulating. So if I were to plug in, notice I still need the minus. Instead of a sine squared, if I used 1 minus cos squared, and I am alpha, then I end up with cos squared minus 1, and then this becomes another plus, right? Because you're going to distribute that. So I actually end up with 2 cos squared alpha minus 1. So there's another version. Why might this be helpful? Well, maybe you want to use something with cos 2 alpha that's only in terms of cosine. See how this one would have coses and sines, whereas this just has cos. So that might be helpful. We can do the same thing replacing the cos squared. So if I wanted to replace cos squared according to this identity is 1 minus sine squared. So I could replace that cos squared with 1 minus sine squared minus sine squared, which gives me 1 minus 2 sine squared alpha. So these are your 3 versions for the cos double angle. So there's your 3 different versions that you can use. This one, again, involves both sine and cos. These ones involve only cos or sine, depending on which one you want to use. So that's when you're going to see that happen in proofs, like when it's maybe more advantageous. So we're going to do the same thing to get the sine of the double angle. So first, let's recall what the sine sum is. I'll give you a moment. So the sine sum is sine cos, cos sine, first angle, second angle, first angle, second angle. And remember, for this one, it stays the same sign or parity. So if it's addition, it's addition. So if I want to do sine of 2 alpha, a double angle, I can think of it as alpha plus alpha. So here we go. sine of the first, cos of the second, plus cos of the first, sine of the second, but they're the same angle. Now, these are the same term. It's just out of order here, so I could flip that. So this is really 2 sine of the angle, cos of the angle. And because neither of these are squared, I don't have all these other options. So this is the only option I have for the sine double angle. Okay, cool. I could do the same thing for the tan. So we learned tan yesterday. The tan sum, if you remember, is tan of the first plus tan of the second all over 1 minus tan of the first times tan of the second. So if I was doing that for this guy, because the two angles are the same, I would have this. So on top, you have the same term, but 2 of them. So 2 tan of the angle over 1 minus, this is the same term, so tan squared. So there is the sum, the double angle sum for tan. Again, these are all listed on your identity sheet, but it's nice to kind of see where they come from because you could always come up with them again in case you forgot. Okay, so that's the double angles. Okay. So the second one today is when we want to find trig functions for angles that are half as large as a known one. Now this one is more, like this one I can explain a little bit more by example. If I wanted you to find the sine of a 22.5 degree angle, well, you don't know that, right? But you do know that that is half of a 45 degree angle, which is something you know. So what I'm saying when I say a half angle is if it's an angle that's half of something you already know. So 22.5 is half of something I know. So, okay, so how the heck am I going to get a half angle formula? I'm going to use some formulas that we already know and adapt them to solve this. Okay, so the first thing I'm going to do is I'm going to start with the one that we already proved, cos of 2 alpha. And I'm going to say this. I'm going to say a couple of things. I'm going to say, let's let 2 alpha be theta, which it can be anything, which means if I solved this for alpha, I want everybody to look at this. This is the big one. This means that alpha is half theta. This is where I'm going to get that half angle situation. Okay. Okay, so now let's mess with cos of 2 theta, or cos of 2 alpha. So cos of 2 alpha, as we know, we have a couple of options for cos of 2 alpha. We can use, let's see, I'm going to use the 2 cos squared alpha minus 1 version. Okay. So if this is true, I'm going to replace these two things with what I know, these two angles. I have said that 2 alpha is replaceable with theta, bingo, which means that this alpha is replaceable with half theta. Okay, so because I made that relationship initially, right, like because this one is a double and goes to half of itself, I can then go, well, if that's a theta, then that would be half of itself. Again, you don't have to prove these again, I'm showing you. So check it out. This is really crucial. This part right here, I've introduced this idea of a half angle. I just need to now solve for it. So, okay, how am I going to do that? I am going to try to isolate this guy. So I'm going to add this one, which gives me this. Right? Everybody see that? I added the one. I'm going to divide by 2. And then careful, I do need to get rid of the squared, so I'm going to square root both sides. So I think everybody can see that one. I would get cos of theta equals square root of, I'm going to reorder this. I'm going to say 1 plus cos theta. You'll see why. It doesn't really matter since it's addition, but there's a reason I'm going to do that. But here's the deal. When you take a square root to solve, it could have been the plus version or the minus version. So for now, I'm going to put plus or minus. I am telling you, though, and this is really important, it is not both. It's not both plus and minus. You will choose which one it is. and I will talk about how we do that. Okay, so there is your cos half angle formula. Okay, let's do the same thing for sine. So if I wanted to do the sine version, then I'm going to use the double angle that uses sine. So I could have used 1 minus 2 sine squared alpha. So that's what I'm using for the second version. So again, instead of 2 alpha, I would have started with theta, and then I would replace this alpha with 1 minus 2 sine squared. Remember, alpha was really half of theta. So there I go again, introducing this half theta. So then I'm going to want to get this alone. I'm going to actually move this over here to make it positive 2 sine squared half theta. And I'm going to subtract the cos, so 1 minus cos. So I moved this guy just to keep it positive. Then I'm going to divide by 2, and then I'm going to square root. So what I end up with is the square root of 1 minus cos theta over 2. That's why I wrote it in this order, because they're very similar, except this is subtraction. Once again, we have that plus or minus, but again, we will choose whether it's positive or negative. It's not technically both. So let's use this to solve that problem that I started with. So we said if we want to know the sine of 22.5, the first thing we should say is, well, I really know that that's half of an angle that I'm familiar with. That's what makes it a half angle. It's half of something you're familiar with. So if I want to find this, then that means I'm going to be using the square root of 1 minus cos of the given angle, not 22.5, the 45. So half of 45 over 2. Now, this is the question out here, right? Is it plus or minus? This is where you have to look at the original angle. And you have to say to yourself, what quadrant is this original angle in? Because that's technically where this would be and what would decide. This is in quadrant 1. So then you would say, well, is sine positive or negative in quadrant 1? And it's positive. So that's how I would know to choose the positive version. Okay, so then let's figure out what's inside. So I have the square root of 1 minus cos of 45 is positive root 2 over 2. Yes, I'm going to simplify this. This, I could make common denominators by changing this into 2 over 2. So I have 2 minus root 2 all over 2 all over 2. Now, be careful. This is the big fraction bar. This is the denominator. So if you have fractions within fractions, I always like to make sure both are fractions. So I'm going to make that a 2 over 1. That way, when I multiply by the reciprocal here, I multiply by the correct reciprocal, which is 1/2. So I'm getting closer. I get 2 minus root 2 over 4. I can do the square root of these separately. The top would be, the top would be 2, square root of 2 minus root 2, and then I can actually do the square root of 4 over 2. And you should do that. So there we go. That's how we do half angles. We could also do it for tan. We have 3 different forms for the tangent version. So obviously tan of the half angle is the same as the sine over the cos. So let's take a look at this. The sine is square root of 1 minus cos theta over 2, and then the cos is 1 minus, or plus, excuse me, cos theta over 2. Now technically, this is the plus or minus thing, but I'll show you how we can figure that out at the end again. So for this one, what I would do is separate them and then and deal with them. So first of all, when you have a square root of the top over the square root of the bottom, the rule is you can do the square root and then of what's inside. So again, as long as the entire top and bottom are square rooted, you can treat them, you can do the square root after you do the division. So that's what I'm going to do. If I do this, then the 2's actually end up canceling, because when you multiply by the reciprocal, they cancel. So I end up with square root of 1 minus cos theta over 1 plus cos theta. That is one of my versions. This one, you will have to do the same thing that we did at the beginning for sine in the past one to figure if it's plus or minus. So there's one version. Okay. Within this, I can do some simplifying. So let's check this out. Notice these are conjugates. So if I multiplied by the conjugate inside, which I can do, if I multiplied by the conjugate of the bottom, that would be 1 minus cos. So I'm going to multiply that by on the top and bottom inside, which is just 1, so it shouldn't change it. When I do that, I get The top is 1 minus cos theta, the quantity squared, because you're multiplying the same thing. I'm not going to multiply it out. I'm going to leave it squared for a reason. Over the bottom are conjugates, so 1 minus cos squared. And you guys know that 1 minus cos squared is replaceable with somebody. Yep, it's a Pythagorean identity, sine squared. Why is it so nice that the top and bottom end up being squares of each other? Or I mean, end up being powers of 2? Well, I'm square rooting and squaring at the same time. So the square root here and the squared cancel, 1 minus cos. And the square root and the squared cancel over sine. I love this version. This version is my favorite version for the tan half angle. So there's the second one. The third version is actually doing the same idea, except I use the conjugate of the top. So the third version would multiply by the conjugate of this guy, which would be 1 plus cos on top and bottom. And you can probably see where this is headed. The top becomes 1 minus cos squared this time. The bottom becomes 1 plus cos, the quantity squared. And of course, I'll change that top using Pythagorean identity to sine. And then I can actually take the square root. Sine on top, 1 plus cos. They're very similar but different, guys, so make sure you know the difference. This one is 1 minus cos over sine. This one has sine on top, but it's over 1 plus cos. So those are the three you can use. Again, I tend to use this one the most. For these two, because you're no longer doing the square root, you don't have to worry about the plus or minus. It will come out the way it's supposed to come out, meaning like if the whole thing comes out positive, it was supposed to be positive. That's why I don't use this as much, because I would have to do more work to kind of mess with that. Plus, I still have a radical, which is really usually kind of nasty for my numbers. So once again, this one is my favorite, this one is my second favorite, and this one is my least favorite. There's my ranking system. Okay. Oops. Okay. So, again, this is me talking about if it's positive or negative. I would like to look at a couple of examples, and we'll talk about how we can figure out if the value is positive or negative. So I guess maybe I'll do these two, but I'm going to do them on another page. Okay. So for example, let's say we wanted to do the cos of 7 pi over 8. Okay. First of all, I don't know pi over 8s. Those are not special angles that I know. But I know that this is half of an angle I do know. The easiest way to figure this out, guys, is it's half of what? Well, think about what would this have to be so that when you multiplied it, you get 7 pi over 8. That means this is half of 7 pi over 4. Now that's an angle I know. So I can do this as a half theta. So while you're still learning, it probably wouldn't hurt to just tell yourself, okay, what is what is my formula for the half angle? And you would go, okay, well, my formula is square root of 1 plus cos of theta over 2, and then I have to decide the plus or minus part. So now you're going to plug in. So you're going to say, okay, well, if I'm doing cos of half of 7 pi over 4, that would be 1 plus, that would be 1 plus cos of this angle I know, because this thing that you're putting in here should always be the angle you know, over 2. Again, I will have to figure out the plus or minus in a second. Okay, so let's see what we got. This is 1 plus cos at 7 pi over 4. Careful. 7 pi over 4 would give me a negative for cos, so it should be 1 plus negative root 2 over 2 over 2. This is where I'm going to put everybody together. I will make the bottom 2 over 1. So then I end up with square root of 2 minus root 2 over 2 times the reciprocal, 1/2. So right now I have root 2 minus root 2, technically over 4, but I can do the square root of the bottom, right? Square root of 4 is 2. But the question is positive or negative. Remember, this is where you have to go back to the original angle. So for example, I need to look at where 7 pi over 8 is. 7 pi over 8 is just shy of 8 pi over 8, which means it's in the second quadrant. So should the cos of 7 pi over 8, something in the second quadrant, be positive or negative? Cosine is negative here. So this should be negative 2 minus root 2 over 2. Okay, so to carry on what we did from yesterday, I want to do a couple of things. Because sometimes we're going to talk about angles having, not knowing the angle, but knowing the relationship. So this is what I mean. So I'm going to do a couple that will involve yesterday's and today's stuff. So let's say that I tell you that I know that the cos of theta is maybe negative. I'll keep it easy for this time being, negative 4/5, and that theta is in quadrant 3. And then maybe I'll tell you that the tan of beta is, let's go negative 5/12, and it's in quadrant 2. Oops. Okay, so this is your given information. So we're going to do a couple of different ones with this. I'm going to ask you to do, let's do the sign difference. So we'll do, careful, beta minus alpha, or beta minus theta. We'll do that one. We'll do cos of theta plus beta. We'll do cos of 2 beta. And we'll do sine of 2 theta. So I'm going to do quite a bit. Then we'll do half angles because they're the hardest. Okay. Okay, so let's do the first guy. To do this, I'm telling you, the first thing you should do is draw triangles for each of your angles. And you should put them in the correct quadrant. So this first angle is in quadrant 3. So I'm going to draw a little triangle in quadrant 3. And I'm going to use this information to label it. So I know that the cos ratio is negative 4/5. Now, you can either make your triangle on a unit circle, or you can use like adjacent over hypotenuse. I do that. I just use adjacent over hypotenuse. And then I always make sure that I do my ratios correctly. So this would be adjacent over hypotenuse, which would mean this is the adjacent side is 4, the hypotenuse is 5. Again, if this is negative 4/5, obviously this x is in the negative. Your hypotenuse will never be negative, guys. So now I can use Pythagorean theorem to get that this side is 3, but careful, it's in the negative, so I have to make sure it's negative 3. Always watch out. If you are not in the first quadrant, you should be checking to see if things are negative. Okay. So there's my first relationship for theta. I need a relationship for beta. Beta is in quadrant 2, so I'm going to draw this guy in quadrant 2. The tan relationship opposite over adjacent is 5/12. Which one of these is negative? Because to become a negative in general, only one of them should be. Well, look at your coordinate system. The x should be negative. This is a nice Pythagorean triple. They're not always nice, but it is today. This is 13. And now we're good to go. So the first thing that you should do on these guys is write out the formula. So like this guy is sine, this expansion is sine beta cos theta. Sine stays the same sign, minus cos the first, sine the second. So the first thing is to use your formula, sine, cos, cosine. Sine stays the same, first, second, first. Okay. Then I'm going to use my information. So do I know the sine of, careful, beta? That's this guy. Yeah, the sine of beta, sine would be opposite over hypotenuse, 5/13. This is why I can't just use like the y value because this isn't a unit circle. That's why I have to actually do opposite over hypotenuse. Cos of theta, go back to your theta triangle. Cos here is adjacent over hypotenuse, negative 4/5. Cos of beta, back over here. Cosine is adjacent over hypotenuse, negative 12/13. Be careful on these. Sine of theta, I'm back here, opposite over hypotenuse. And then we're just multiplying. Top times top, negative 20. 13 times 5, 65. Minus, this becomes negative times negative is positive, so positive 36 over 65. This is really, since it's minus, I could just make it plus a negative, and I end up with negative 56 over 65. So there we go. That wasn't too bad. Let's try this second guy. First things first, if you want to pause it and try it yourself, you can. This first guy, if I were to expand it, I would get cos, cos, remember, theta, beta, switch minus sine, sine. Yes, you want to memorize these. This is what I do. I get it all ready. Then I go back to my pictures. Cos of theta, cos of this guy was negative adjacent over hypotenuse, negative 4/5. Cos of this one, adjacent over hypotenuse, negative 12/13. Sine theta, opposite over hypotenuse, negative 3/5. Sine of beta, opposite over hypotenuse, 5/13. Here, we're going to get positive 48 65ths. And then this is going to be, like, I just do the negative times here. So like negative, negative, positive would be positive, and then 15 over 65. So I ended up with 63 65ths for that answer. Okay, cos of 2 beta. I have 3 options. You can use whichever one you want. I think I'm going to do 2 cos squared of the angle beta minus 1. I'm going to use that one, but you could have used any of the 3. So to get it ready, I'm going to do 2 blank squared minus 1. So then I just need cos of beta. The cosine of beta, adjacent over hypotenuse, negative 12/13. So then I have to square first. That becomes 144 over 169 times 2. Remember, a whole number times a fraction. This is just over 1. So then I end up with 288 over 169. Yes, you can use your calculators on this. Minus 1. In fact, I'm going to do it. Let's see, 288 minus 169 gives me 119 over 169. Yeah, you're welcome to use your calculators here, guys. You can show me your work, but use your calculators. Whew. And last but not least, sine of 2 theta. The only expansion for that is 2 sine theta cos theta. So 2 times blank times blank. Sine of theta is opposite over adjacent, negative 3/5. Cos of theta, adjacent over hypotenuse, negative 4/5. This is over 1. Top times top times top ends up being positive 24 over 25. Okay, and then I know I focused on sine and cos, but you could do tangent. We're going to talk about doing the reciprocal functions in class, which is crazy. And last but not least, I didn't get a chance to do half angles, so I am going to copy this over to my next page and try some half angles. Hopefully. It's being a little slow. Okay. Oops. Let's try that one more time. There we go. Whoa. It's a much larger version than I need. Hold on. That's better. Okay. So let's try some half angles. So how's this going to work? So let's do cos of half theta. Okay. So first of all, the first thing I would do is do my formula, which is 1 plus cos theta over 2. And remember, we have to figure out if it's positive or negative. So, okay, let's start the ball rolling. Square root of 1 plus the cos of your theta relationship. Remember, the cosine here was adjacent over hypotenuse, so negative 4/5 all over 2, which gives me, let's see, if I wanted to put these two guys together, I could just make this 5 over 5. So I have square root of 5 plus minus 4 really is 1/5 over 2. Careful, this is the denominator. It's not a fraction. Make it over 1 so that you get the right square root, 1/10. I can square root those separately. Square root of 1 is 1. People leave it at square root of 1 all the time, which is so weird. It's 1 over square root of 10. I could rationalize this. So the final answer would be root 10 over 10. Now, we haven't decided yet whether or not it's positive or negative. How do we do that? Now, this is tricky. We need to figure out where this angle is. So we need to figure out where is half theta. Well, okay. They said theta itself is in quadrant 3, right? So think about this. If you have an angle somewhere in here, you know that that angle is going to be bigger than 180, but less than 270. If I need to figure out where half theta is, just divide each of these by 2, right? That'll tell me. So this is saying, all right, well then that means that theta over 2 would be between half of 180 is 90, half of 270 is 135. Where is this angle, guys? Where is theta over 2? 90 to 135 is in the second quadrant. So that means this angle, the original, was in the second quadrant. So should cosine, which is what I was doing, in the second quadrant be positive or negative? Yep, it should be negative. So my final answer is negative. We'll probably have to do a couple of those together until you guys get really comfortable with it. But that's how that works. So you kind of have to use your information about this angle to talk to you about where half of that lands. Sometimes it lands in the first quadrant, sometimes it lands in the second. If you had a really big wrapped angle, then that you'd have to do a little more work. Okay, that's it. You can start trying these over the next few days. There's no rush. We will talk about this in class and do some more proofs in class, and I will see you then. Bye.